Um, Here's a example project that we're going to start out with Hello World. What I've done is I've downloaded the Visual Studio Community Edition, Visual Studio 2012. Let's see what I've got here. Yeah, Microsoft Visual Studio Community 20, not 2012, 2017. And I'm going to start out and I'm just going to make a Hello World project. And right off the bat, we have a lot of different choices. We have a console application, desktop application, or an empty project. I'm really not sure what the difference is between a desktop application and this other, and the MFC one, if it's on here. Well, I don't know if it even has MFC on here. Okay. You would think that it would have, I guess I don't know if they took that out or if MFC is not available in the Community Edition. That's interesting. But anyway, so really on Windows, there's if I understand it correctly, I think that the console application is in a way the main. You get an int main with arguments, and I believe in that. It's not exactly the lowest level, actually. It's kind of backwards. It looks like it's the lowest level, but actually I believe that the console itself is a sort of construct, and that there's a different one, either WinMain or something. And I think that when you make this kind of application, you're actually getting something that jumps into that, but it's still compatible with standard C++. I think. I could be wrong about that, and we might want to kind of dig into that a little deeper. But to keep it simple, to keep the code simple, I'm going to create one of these. I might create one of these after we do the Hello World, but I also want to get to showing dynamic libraries and static libraries as well. So I'm going to create this console application. I'll call it Hello World Console. Really not sure why it takes this long to create a project that just has a hello in it. Okay, and so here's one way that Visual Studio differs from if you built this in, say, another IDE, like, say, Code Project or C-Line. You have these standard AFX, these precompiled headers. So it's, even though you said you want just a simple console application, you still have this extra junk in here in these precompiled headers. And I'm not a fan of precompiled headers at all. What they are basically is a band-aid over the fact that the Windows headers are so huge and full of crap that they take forever to build. And on top of that, it's very easy with a C++ project to end up with extra stuff in your headers that maybe you have included that you don't necessarily need, and that'll make your build times take longer. And the reason I'm not a fan of the precompiled headers is that it's an additional layer of things that can get out of date. It's an additional layer of things that you have to get the settings right if you are upgrading a project or etc. It doesn't, and it if it's working correctly, it doesn't change how your code works. But if it's working incorrectly, then it can cause things to be out of date. And so that's why in general, I'm not a fan of things that don't actually implement anything that you couldn't have without them. And that's kind of what the standard AFX, these headers are. And I believe the reason it's called standard AFX is it originally came from a thing called active extensions or something like that. Active framework extensions, I don't know. But basically what you do is you have stuff that you're going to include in every project that, everything that your program needs, you put it in this, which again is another design anti-pattern for C++. So it's kind of right off the bat encouraging something that you shouldn't even be doing, in my opinion. You should not have a global header that includes everything that you might need anywhere. But we'll table that for a minute. We can make this build without the standard AFX or not. But so we've got this int main, there's the return 0. And here, I'm going to check my live stream, see if anyone's watching. One viewer, probably myself. I don't know if I can see who the viewers are. Anyway, so here I'm going to include I'm going to include IOString. No difference between the quotes boy, if I'm on camera, I suddenly forget how to type. Okay, so what I'm doing here is I'm going to include the cout so that I can do the hello world. Of course, most of the people watching this stream probably already know this. A couple of things here. One is that, at least according to things I've been seeing lately, you should use this \n and not the way that I always saw to do it when I was learning C++, like this. And I think the reason why is because this flushes the stream, which you might not necessarily want to do every time that you just want to cause a line break, or go to a new line. You might not necessarily want to flush the whole stream when you do that. It's probably a bad habit to get into, to be always seeing stood endline everywhere. The other thing is that there's proposals right now in the C++ standard to replace this stood cout with something like a variadic template args, not printf, but something that can take variable arguments, kind of like string.format in C#. And the reason why there's been not exactly controversy, but why not everybody likes the stood cout is you're told that using this syntax for printing, as opposed to, now definitely don't use printf, but just for example, the reason the printf syntax looks different is you might do like this, and so you can kind of keep your format of what you're printing, like how you're doing it, separate from what the variables or arguments you're passing to it are. And so, like, if you were, say like this, you say messages, hello world or whatever. But the problem with printf is that it's not type safe. And this syntax with these shift operators, excuse me, syntax was a way to get type safety and a way to get something like variable argumentless when C++ didn't have those yet. And the reason why is that because this is an infix operator here, this thing I've got highlighted, you can keep chaining it in a way that you can't just keep adding arguments to a function without having variadic arguments. So we had to accept a certain clunkiness in the syntax of it in order to get that type safety. But now that we have variadic templates, we can do other things, and we might not need to have this syntax anymore, but it's not standard yet. So for this example, I'm just going to do stood cout and hello world. Now, when I build this, which it should build, let's see. Build and run, okay. Now, first thing, of course, is it doesn't pause on exit. And I don't know if there's a setting you can do to make Visual Studio pause on exit, debugger setting, but I just always put a breakpoint on the return value. So do that. Oh, let's get it back. Okay. So here we have just the simple hello world we got to work. But what's actually going on when we include this file here is it's looking in a standard system include directory for this file. Let's see if we can open the document. And this is what it looks like, and it's actually getting dumped directly into our code. What happens is that the compiler runs and consumes this program, and when it sees the include, it drops the text of this right into the program as if you had typed it in. In fact, just by way of demonstration, I might get a warning from the compiler when I do this, I'm not sure. But just by way of demonstration, I could do this. And this should work just the same, except for there might be something to do with folder directories. I'm not sure. Let's give it a try. Ah, look at that. Yeah, okay, I was right. I guessed that this would work just based on the principle of the thing, but I hadn't actually ever tried this before. So as you can see, when you do an include file, it's actually the same thing as just dumping the whole file in there. So it's got all these declares for what is things that are accessible from that header. But once, so the include file gives you the names of things and definitions, but then it produces an object file. And you see where the object files go by looking in the output files. This is where this int dir macro, which I'm not really sure what int dir stands for. Internal dir, I'm not sure. But if we go to actually, I'm not really sure where Visual Studio is keeping the file for this. There we go. Okay. So here, it's putting it in, yeah, here we got the object file. So it's this debug subfolder of the project. And now, of course, if we were to change to a release build, then it would create another folder called release. And here again, we've got the object files. And you want your object files segregated by what type of build they are, so because if you accidentally link in the wrong one, at best you're just getting an unoptimized version or one with debug information, etc. But at worst, you could be trying to link in one that's different CPU architecture. In fact, maybe we should take a look at that actually. So here we're building an x86 one, which means it's 32-bit. With modern code, if you're starting with new code, unless you're running on older computers for some reason, there's really no reason not to build everything 64-bit if your libraries that you're using can also be built 64-bit. So I can do that. And now what's interesting here, oh, okay, so this is what it did. It created an x64 folder for that configuration. That's interesting. I wonder why it didn't do an x86 folder for these. That's interesting. But another thing I want to point out is that in addition to these ones underneath the project folder, it also created ones that are on the top level and with similar naming, debug, release, x86, and so forth. And those folders being global, the reason why it's beneficial to have them there is that if you have multiple projects, like with DLLs or something, having a shared folder at the solution level rather than the individual project level helps ensure that you can get everything ending up in the same folder for when you run it so that it'll find the DLLs that it's looking for. Some people use pre-build steps, pre or post-build steps to copy the build out of, say, it would be, out of a local folder. They build to the same one as the object, and then they copy it out to some other one or to the dependent project. I'm not a fan of that, just simply because, just like with the precompiled headers, it's an extra step to the build that can fail, and it's just a fiddly thing that you have to get right, and whereas having the final linker output just have it going to a solution folder altogether, I think is much simpler to do if you can do that. So we'll get back here. And then the other thing that's going on here is that it's linking. Since we've just got the one project here, it's a pretty simple thing. It's just linking all the object files together into an executable. However, something to be aware of is that there's linking, and then there's also, if you were building a static library, there's something called, I think it's called library lib or something, but anyway, the difference is both of them are combining object files into a unit together, but the linker is actually determining addresses for things and actually generating the connection between the object file and how it's going to load stuff from the system. Whereas if you are linking a static library, it's actually just dumping a whole bunch of object files together into a file. You could get a similar, it wouldn't work because it probably didn't have the right headers or whatever. You could get a similar effect by dumping a bunch of things together with a zip file with no compression. That's not literally, but that's essentially what a static library is like. Anyway, so back here, linker, we go to, let's go to the command line. Let's look at that. So the command line to the linker is pretty crazy. Actually, let me back up and show you the difference between the command line for the compiler and the command line for the linker. So the command line for the compiler is adding, it's going to specify, now we won't see it here because this is the one that's for generic for each file, but it's going to have, it's going to pass some preprocessor defines, and I think that's the machine. That's the output, I think. I'm not sure. Anyway, what you won't see in the compiler command line is anything to do with linking in other libraries. You will see include file directories, and those ultimately come from this option up here, the include directories. But on the linker command line, if you look at, let me highlight these things right here, these are additional static library files. And in fact, that's what I was talking about with the static library files are sort of like a bundle of OBJ files, of object files. What's in these are basically pieces of stub code that know how to call the operating system, low-level code. It's wrappers for operating NT whatever kernel calls or whatever, and they're actually, I mean, really they're more like helpers that wrap these things, but most programmers will hardly ever actually skip those and go to the low-level things. If you were writing an assembly language program or something and you wanted the least number of dependencies possible, you might skip these and go directly to the operating system, but usually you call it through these kernels. But what I want you to understand here is that all of these lib files are in principle not any different than something that you could create as a static library project yourself if you had the source code for it. But what they are is these, I believe, I'm not sure, but I believe they're part of the SDK. I could be wrong about that, but I think they're part of the SDK. But one of these files, probably user32, or maybe could be shell32. One of these actually has the definition in it of the lowest level function that stood cout eventually reaches after you unwrap all of the layers of, if you unwrap all the layers of things that this is calling, you would eventually get to something that's in one of these lib files. And so if you took one of these out, see if there's a, Okay, right here. So if you took these out, actually, I'm going to take a guess and say that maybe it's in user 32 is where the IO stream is. Oh, that's interesting. Apparently it doesn't depend on that library. Let's take another one out. Okay, active. Let's take kernel 32 out of there too. See if that's the one that it's using. Interesting. Maybe I'm not understanding how that, if that's taking that. Oh, maybe it's shell 32. Yeah, that might be it. And it's kind of interesting here. I can take these references, these things out, and it so far doesn't seem to be affecting the output. And of course, it's because it's a simple program that's just doing a std out of a message. But it also shows that a lot of these ones, these default includes, are in there because you might need them rather than because you necessarily need them for every program. It's a standard set of include files that they believe that you're going to need. Huh. I wonder if I can take all of that out. Ah, still builds. Okay, well, I'm misunderstanding something about what I'm taking out here, I think. Oh, it looks like it's still actually there on the command line, so that... It's probably an option for default libraries. What I'm trying to do here is I'm trying to generate an error that says okay, I'm not really sure what I would have to do to cause an error with this, but to put back what I took out, I'm just going to go over here, and I'm assuming that the release build libraries are the same as what I just took out for debug, so I'm going to put them back. And this is actually a good example of one of the things of why, of my motivation for starting this this show, is that if you look at this user interface is not very nice, and it speaks to this idea that it seems like with Xcode is only marginally better. CodeBlocks is a little bit better. Visual Studio, I can't believe it. As one of the best IDEs, I can't believe why Visual Studio is still so bad for this, particularly for C++. But basically, these things like this, you see I'm having to edit this in this little window here, and if I click on this, it's really not any better. I've got this little tiny window here. I can see like 2 lines at a time, and then I've got this not very good user interface here that, like, okay, evaluated value, why is it evaluated? And, it seems like this could be a whole lot better, and it seems like these settings like this that are so important to getting something to build correctly, to get to a bin file, are just treated very as like this embarrassing detail that nobody wants to care about. And so I think that there's this feedback loop of the tools are not very good for editing these things, and the knowledge is there, but it's not as widespread as basic programming knowledge is, or as just programming knowledge in general is taught. And so I think it ends up being this kind of thing that nobody wants to touch, and once you get your project building, you don't touch it anymore, and then if you have a problem with it, especially if it's not your code, you have no idea how to fix it. And I don't think that's a very good situation for the world in general. I can't stand, if I have a problem that happens intermittently, or I have something go wrong with the project that I'm trying to build that I don't understand, I don't want to just fix it. I want to understand why it was not working right. And anyway, so put that back. Now we've got this right here. I talked about the includes, and I talked about how it gets linked. But what if we had, let's say, a standard or a static library? Excuse me. Project static library. In fact, to show the difference between a static library and a dynamic library, DLL, I'm going to add both of those together because I think it makes more sense if I can contrast the two of them. Okay. Okay. So the static library is going to act much more like object files that are within your own project, whereas the dynamic library is going to act like a separate executable almost, in terms of it has its own, it gets linked separately. And you can see this by, if you look at right here, the static library has this thing called librarian, whereas the dynamic library has something called, has the linker options. So the linker options for the dynamic library are much more like an executable, whereas the linker options for the static library are much more limited because it's not producing the full linking step. It's just doing this thing called librarian. It has very few options to it. And then so if we want, let's say we put a source file in here. I'll just make it a class just to make it easy to add both files. I'll call it and so I think I'll just take this out of here, and I'm going to say void. Maybe well, yeah, I'll just leave that like that. This one here has already got a file in it. I'll just I'll just add it the same way though. With, of course, add new item. Okay, call dynamic. What I'm doing here is I'm just trying to create some methods that can be called from this. Okay, so let's say we've created these two things, and we want to use them from here. I'll take this out, take this out. Now, let's do the static library first. So we call static.hpp. Let's say and then of course we get errors. Can't open the source file, call static undefined, etc. And the problem, of course, is that it doesn't know to look for where to look for this file, even though it's in the same solution. Visual Studio doesn't automatically add the other directories to the other project because it doesn't know what things should depend on what other things. And so, and then also I want to mention that this quote marks here, the only difference between these two is the order of things that it looks in. If I were to do this, it would look in the system directories first and then look in the project directories. Or if I do it in this order, it looks in the project directories first and then the system directories, which are the system directories be like where IO stream is. So the first thing I need to do here is set the include directory, and here's another fiddly little awful interface that opens another fiddly awful interface, which if you click on opens another thing to finally get to something where you can actually select. You couldn't make this up. Okay, so I'm adding the hello static world or static lib, and the file that I want to include is called static, is just sitting there in the project folder. Usually when I make, or sometimes when I make projects, I make a folder called include and another folder called source. Most of the Windows projects I've seen just have it, or the ones I've seen lately just have them all dumped in the same folder together. I'm not really sure if it makes much difference, but I'll just leave this how it is here. Okay, so I'm going to include that. And now let's build. And we get another error. Actually, well, it didn't fix the first error, did it? That's odd. Must have set the wrong setting. Okay. Oh, I chose the, no, that's it. I chose the right one. No static lib. Okay, so one trick is to take this out of here and put it into browser. You can see what happens. Can't have the semicolon. Okay, so it should be seeing it. Oh, it's just .h. Okay. So the other thing is I misspelled it. I put HPP when it's just .h. And now let's build. Okay, now we have this unresolved external symbol, etc. And so first of all, you are going to get a lot of gibberish here with this underscore underscore and C declare and question mark at yak z. What in the world? Well, so C++ does this thing called name mangling, and the reason it does that is because it's meant to be interoperable with C, and as such, they're both based on a very old linker technology. The basic technology underlying the linker dates back to older even than C. It dates back to linking assembly language files. In fact, that's also why we have object files and static library files. They all date back to time before even C with when you had assembly language. And those linkers are not aware of type information because in C++ you can overload the same method name with different argument types. Or I mean, one of them could be a static function of or name. One could be a global function, and the other one could be a member function, etc. But since the linker doesn't understand any of that, the compiler has to tag the name with all this extra gibberish in order to disambiguate the two different names. There's a way to remove that if you do extern C, but we'll only talk about that if we are trying to build a C project or a mixed C and C++ project. So anyway, the first problem you've got is these messages. Linker errors are often they don't fully match what you're seeing in your source code. They have, the names are going to be a little bit strange because they're mangled. And then the other thing that makes linker errors hard to troubleshoot is it doesn't really give you any idea why or where in your program the problem is. Like if I did something like this, and I have a misspelling, it's gonna have a line and a file associated with it. But when I have a linker error, it's not associated with any particular file or any particular line. It's just saying somewhere in this project something's missing. And but the thing is, so you have to, if you don't know why the thing is missing, you kind of have to use some deduction. If you're walking into a new project or trying to get a new project to build, and you get a whole slew of errors, sometimes you can tell just by kind of looking at the names. Some of them will have to kind of go together, like maybe if there's a lot of them that are talking about, I don't know, maybe image resizing, maybe you're missing a reference to open source image library or something, or if a lot of them are talking about, say, sockets, maybe you're missing the WinSock library or something like that. And then in this case, we know which one is missing. It's this called static, and so we need to configure the static library. And actually, we don't need to do that. What we need to do is add a reference here first. Set that. I think this will build. Yeah, so there's two ways we could have done that. There's this way that I just did. If I run it, you can see it says hello static world. And then the other way that we could have done it is instead of doing this reference here, we could have added we could have gone into properties, linker, input, add, let's go up top here. Add, what's this going to be called? I think this is what it'll be called. Let's look at the bin folder. So, Oh, it's going to go into the global one. Here it is. Yeah, hello stack lib. Good to know this is where it goes to. I might need this in a minute. Okay, so we can set this, and we can go to the directories, say library directories, and actually we don't want to use the hard-coded path. What we want to use is the output directory. Solution D or platform configuration. In fact, this right here is what's generating that x64 on there by using the platform macro there. I think. Or maybe it's the intermediate directory. One of those two. Okay, go to directories and library directories. And add this. I think I can add that way. Let's see. Okay. Now, if I rebuild. And it does work. So, when you add a reference to the project using this, the linking steps that will be undertaken ultimately will resemble what I just did. But it's much better to do it the first way that I showed. And the reason why is that when you have the settings like that, that setting is very specific to what I basically did was I added this library file directly. And you can do that if that's all you have is those library files, or if you downloaded something that's distributed as lib files. But you have to make sure that you're linking to the right one for your configuration, both for whether it's debugger release and for your architecture that you're compiling to. And I'm not sure about this, but I think that if you do it this way with directly linking to it, I believe that you don't get the dependencies managed. Let's see. Let's see, dependencies. No, not external dependencies. What I'm looking for, build order. That's what I'm looking for. Looking for project build order. Maybe it's under the solution. Project dependencies. Yeah, so if you add a reference to the lib file directly, then it doesn't automatically create a dependency between the program you're using the library from and the other thing. And so that's why you have to put why you want to put that as a reference using this setting right here. I've seen people set up projects where they manually set the linker like I just did here. I'm going to take this out now. Input files, take this out. I've seen people set up projects like that, and what happens is that, kind of like with the precompiled headers, but much worse, you can end up in a state with something that's out of date and doesn't get updated, or you're ending up linking a library that's not for the exact architecture that you're building. So remove that. Okay. Now add this as a reference. Works. Okay. And then the other thing I want to try is, or want to show, is the dynamic library. Now, I'm going to include a column dynamic.h, and I'm going to add that directory. I want to go to projects, include directories. Add a new one. And I also want to go to here, and I'm gonna do call bank. Okay, so now once again we get the unresolved error, etc., etc. However, okay, so I'll go ahead and add this reference. Okay. So here, it didn't open the lib file. I think this might be a setting on here to generate import library. Well, there's the import library out to your target name. And the output here. Maybe, let's try building this. This is up to date. I'll go to the output library. Or go to that folder. Okay, so what it's looking for is this hello dynamic.lib. And it's not finding it when I build this. See this. What that library, right, that .lib file is kind of similar to what I was talking about with the stub system libraries. However, what this is it's a stub for the things exported from this. Oh, and I think I know why it didn't generate it. So unlike the static library where this was automatically global, or not global, but automatic, well I guess it is that too, but it was automatically exported. For this, I believe, what's the syntax? DLL export? I forget how the syntax for this looks like. I'm used to using a cross-platform macro for that. I'm going to look this up real fast. Okay. So, what I've added here, and let's see, do I need to, why, how does that work? I don't know if I need to do that. Let's see, that's how you declare it. Then how do you define it? Okay, so what I'm getting hung up on here is I've added this to here, but it's saying I can't have it defined two different ways. Maybe I have to do it again here. Let's see if that's what I need to do. Okay. So what just happened is that I've created a lib file by exporting something from that DLL. It didn't create it before because there was nothing to export. And word wrap here. And the lib file, I was hoping it was a text format, but I guess it's a binary format. But you can see it still. this what it does is it lists what's being exported from the program. And see, because the thing is that the methods in a DLL are actually ultimately, I think they're ultimately described by they're in a table, and I think they're mainly like function 1 in the table, function 2, etc. And what the lib file that's generated does, if I understand it correctly, there's better videos talking about DLLs, but if I understand it correctly, it's creating a trampoline or thunk or something that is going to look up the method and replace itself, or replace the body of the lib file function with a jump directly to where it needs to go. And the reason it's doing that is that the whole point of a dynamic library, why it's called a dynamic library, is that the final linking or the final connection between what's being called and where the method call goes is not done until runtime. And that's so that the file can be replaced and something else will be called instead. But if I didn't use this deconstruct DLL export, it would never be visible from outside the DLL, because you need to do something to get it to be put into that table that says that the thing's callable. Now if I run this, I'm not sure if it's going to work or not. Let's see if it works. Okay, it worked. I'm not sure if this is something that changed or if I didn't understand how it worked before or whatever, but I thought you had to do DLL import to actually call it, but maybe you don't, at least maybe not on Windows Visual Studio. But anyway, so that's getting static and dynamic libraries to build and to link. I had other things planned for tonight, but as you can see, it's pretty late. This show normally would start at 7:30, but I had some technical issues with the webcam and the microphone and stuff, so we didn't start until about 2 hours late. Usually this will be at 7:30 on Mondays, and next week hopefully we'll get to some of the other agenda items that I had here for the episode 1. We pretty much just covered section 0 and section 1 here, and next time I might just skip ahead next time and download and build this Diablo devolution thing, and then maybe at some point I'll talk about these things as well. Sometime in the future we'll probably be building MAME. I'm not sure how we're going to manage that because building MAME takes a long time, so I'll have to build only part of it. But anyway, yeah. So tune in next week and see those. And then this video here, I hope that what we did was we covered how includes work. We talked about project settings, talked about compiling and linking. We talked about which libraries are automatically put into the executable. And not sure what I meant by that, put hello world into a header. I guess that means call it from the static library. And we also talked about the difference between static libraries and DLLs. Thank you for watching, and I hope you continue to watch these. Thanks.